Alright, hi class. We're going to be going over a few different things today. This is going to be mainly about the periodic table, elements, ions, and a few other things, so please pay close attention. So as you can see right now, we've got a periodic table set up, and I just wanted to review a few things with you guys before your test. So to start off, I'd like to just point out a few things. Whenever we talk about valence electrons, we're always talking about the numbers up at the top over here. So if we talk about, let's say, our first family or group, the number of valence electrons is going to be labeled at the top. So valence electrons are found at the top. If you are going to be dealing with any of the valence electrons over here, we do not consider the first digit. So it's going to be 3, 4, 5, 6, 7, and 8 over here with the complete shell for the last family. So when you see 13, 14, 15, 16, 17, and 18, do not consider the ones. So this is 1 and 2 over here, and we skip all of these. We don't need to know these for class. The next thing that's important to know is going to be the periods. Periods are the rows. So when we're talking about periods, you're talking about the numbers that you have right here, 1, 2, 3, 4, 5, and so on. For the purpose of our course, we're only going to be limiting ourselves to the 4th period because we only go all the way up to calcium. So we're only going to be dealing with all of these elements over here in this box that I'm making right now. So, with that being said, the first 20 elements, you need to know their symbols and their names. You'll be given a periodic table, but the periodic table like this one will not have a name. So if we take a look at, let's say, Si over here, you should know that Si is actually called silicon. And that goes for anything within this box over here. You will need to know every single chemical symbol and their respective names. However, in terms of period, really the only information that you're going to need to know is that the period, so these 1, 2, 3, and 4 on the side that you have over here, are going to be representing the element's energy level, or it's also known as electron shells. So let's say we take carbon for an example over here. Carbon is in the 2nd period, which means that it's going to have 2 electron shells. Now with reference to the Bohr-Rutherford model, we have a nucleus where in the center you'll have the number of protons. So in this case, protons is going to be the number right here at the top. It's 6. And when we talk about energy levels, it's going to be these little arcs that we draw. In this case, we're going to have 2 because we are in period 2, and we are going to fill them out with the number of electrons. We have 6. That means the first is going to be 2, and the last, the valence, is going to be, sorry, that's a mistake, 4, since we can tell from the valence right here, 4. Now some of you might be wondering how I got 2 and 4. What you need to remember is that the first energy level and so on have maximums in terms of how many electrons can be found inside. The first energy level always has a maximum of 2. The second energy level always will have a maximum of 8. The same goes for the third. And since we're stopping with calcium, the maximum, or the 4th valence shell, will have a maximum of 2, since calcium's the last one we're going to. So what you need to remember is 2, 8, 8, 2. These are the maximum number of electrons you can have in your energy levels, your electron shells, that are denoted by the periods on the left, which is the row. So now we're going to go over just a basic where things are found on the periodic table. Most of you should remember this. We've got a little step-like line over here, which is going to be our basis for separating non-metals, which are on the right, metals on the left, and metalloids that usually follow, metalloids that are on and around the staircase. So if we're going to go by color, your nonmetals are over here. Your metals are going to be found pretty much all of the rest over here. And then your metalloids are going to be on the staircase that will be right around here. So this is a general idea of where you will find different things. Now if we're talking about their properties in terms of ions, what you need to know is that nonmetals, since they're found in this general area, they will be the ones that gain electrons when becoming ions. They're the ones that are going to have a positive charge. Metals over here, since these are the ones we're going to be focusing on for this course, they have few valence electrons. So it's easier for them to lose their electrons so that they go to the next full shell than it is for them to be gaining way more. So for example, if we take sodium over here, sodium has one valence electron. It's easier for it to lose that one valence electron and go to the next full shell that it will have, rather than gaining the 7 more electrons it needs to have a full shell. So this means that in general, all we really need to remember is that metals over here will have a positive charge, whereas nonmetals over here will have a negative charge when it comes to ions. So for example, you'll have Na plus versus, if we take fluorine over here, Fl minus. And the number that goes in front of the charge tells you how many more or fewer electrons you have. So this might be a little confusing, so let's go over this in more detail. So sodium over here has a positive charge, but magnesium has a 2+. This is because of the difference in electrons. So sodium has 11 protons in its nucleus. If we're going to fill out the same amount of electrons, we need 11. So it's 2 and 8. But what happens is, because it has a positive charge, it's not going to have that valence electron of 1 anymore. It's going to be lost. It lost its electron. So what happens is, we have 11 positive charges. We now have 10 negative charges from our electrons. Keep in mind this is an ion, it's charged, so we no longer have the same value of protons, or same number of protons and electrons. So when we add these up, our 10 negative and our 11 positive cancel out to leave us with an overall positive 1 charge. The same thing applies with magnesium, except for magnesium has 12 in its center, or in its nucleus. It's going to have the same number of electrons as an ion. However, it will have a charge of +2 because its number of protons is 12. It now has 10 electrons, and when they cancel out, you'll be left with a 2 positive charge because you have 2 fewer electrons than protons. So when you have a positive charge, that's because you have more protons than electrons. However, keep in mind the number of protons will never change. It's only the number of electrons that can go above or below its original value. Now let's just take oxygen as an example. Oxygen is going to have a 2- charge. The same applies in this case. We take our number of protons. In this case, we have 8 protons. Actually, that's going to go over here in the center. 8 protons. We've got how many electrons? Well, if it's got 2-, it's because it's got an overall charge of 2-, 2 extra electrons. So normally it has 8, which would be 6, but it's now got a full valence shell. We have 8 protons, positive charges. We've got 10 electrons. When we cancel these out, we'll be left over with a -2 charge, which is why O, or oxygen, has a charge of -2 as an ion. So ions are always charged based on the difference between protons and electrons. So just to finish this off, I'd like to remind you that not only will you need to know things about ions, the number of protons, the valence electrons, the period, which means how many electron shells or energy levels it has, but you'll also need to know the names of the families. The 4 specific ones that we need to look at will be right here based on the arrows. And you will need to know their names as well as their chemical properties or what's specific to them. Number 1 is going to be your alkali metals. Now, the metals, or the alkali metals, are highly reactive with water. This is also described as they react vigorously with water. Your second, number 2, is going to be the alkaline earth metals. For those of you that need help remembering, usually what I do is I just remember the first one is the alkali metals, the second one we add an earth to it. For 3, over here we have the halogens. They are often used in cleaning products. And number 4 are the noble gases. What we need to know about them is that they are completely unreactive. They will not react chemically with anything that is present. So these are the 4 families you'll need to know for your test, as well as other things, other upcoming tests and quizzes. So hopefully this has been a good review of a few things that pertain to the periodic table. I'd also like to just mention that you will need to know things from Chapter 1, such as which scientist, what they said, what models they came up with, and how it affected the evolution of the atom. So just as a review, you should remember J.J. Thomson, Dalton, Bohr, Rutherford, and what they've each said, each experiment, and what discoveries came out of them. If you have any questions, again, please feel free to come see me during class, at lunch or recess. And again, best of luck with your studies.